Welcome to the 10th video of VCAA Specialist Maths 2021 exam papers. In this video, we will present exam paper 2, section B, question 3, which consists of 3 parts. Most students handled section 1 of part A well. However, the common error in section 2 of part A was incorrectly placing the brackets. In section 1 of part B, most students handled this question well, correctly applying the chain rule to obtain the required form. However, most students did not score well in both sections 2 and 3 of Part B. In Part C, few students made a productive start. Of those who did, only about half reached the correct answer.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Specialist Maths exam paper series. This is section B of 2021 exam 2 paper. There are total 6 extended response questions in section B. In this video, we will present the third extended response question, which states that a thin water vessel is produced by rotating the graph of y equals x cubed minus 8 about the y-axis, for y values are in the closed interval from 0 to h, as shown in the diagram. There are 3 parts in question 3, and part A contains 2 sections. Section 1 is to write down a definite integral in terms of y and h for the volume of the vessel in cubic centimeters. Section 2 is to find an expression for the volume of the vessel in terms of h. There are 3 sections in Part B, and the criteria in Part B is that water is now poured into the vessel. Due to the crack in the base, water leaks out at a rate proportional to the square root of the depth h of water in the vessel. That is, dv by dh equals -4 square root of h, where v is the volume of water remaining in the vessel in cubic centimeters after t minutes. So, section 1 is to show dh by dt equals -4 square root of h over the product of pi and h plus 8, or in parentheses to the 2/3. Here we continue to explain Part B of question 3. Section 2 of Part B is to find the maximum rate at which the depth of water in the vessel decreases, and also find the corresponding depths in centimeters. In section 3, let h equals 50 centimeters for a particular vessel. The vessel is initially full, and the water continues to leak out at the rate of 4 square root of h cubic centimeter per minute. The section is to find the maximum rate at which water can be added in cubic centimeters per minute without the vessel overflowing. The criteria in Part C is that the vessel is initially full, where h equals 50 centimeters, and the water leaks out at the rate of 4 square root of h cubic centimeter per minute. When the depth of water drops 25 centimeters, extra water is poured in at a rate of 40 square root 2 cubic centimeter per minute. The question in Part C is to find how long it takes for the vessel to refill completely from a depth of 25 cm. Now, let's come back to deal with Part A. Section 1 of Part A is to express the volume in a definite integral in terms of y and h. Since y equals x cubed minus 8, x can be written to cubic root of the sum of y plus 8. Hence, the volume v equals pi multiplies the integral from 0 to h of x squared with respect to y. Section 2 is to find an expression for the volume of the vessel in terms of H. Based on the integral expression of the volume in section 1, after being integrated, the volume equals 3 pi over 5 multiplies y plus 8, or in parentheses to the 5/3 valued from 0 to h, which equals 3 pi over 5 multiplies open square bracket h plus 8, or in parentheses to the 5/3 minus 32, close square bracket. Since the criteria in part B is that water is poured into the vessel and at the same time, due to a crack in the base, water leaks out at the rate dV by dH equals -4 square root of h. Section 1 is to show that dH by dt equals -4 square root of h over the product of pi and h plus 8, or in parentheses to the 2/3. Based on the expression derived from part A as well as dH over dt equals dH by dV multiplies dV by dt, it follows that dV by dH equals 3 pi over 5 multiplies 5 over 3 multiplies h plus 8, or in parentheses to the 2/3, which equals pi multiplies h plus 8, or in parentheses to the 2/3. So dH by dV equals the reciprocal of the product of pi and h plus 8, or in parentheses to the 2/3. Hence, dH by dt equals -4 square root of h over the product of pi and h plus 8, or in parentheses to the 2/3. Now let's move to section 2 of part B. Since dH by dt equals -4 square root of h over the product of pi and h plus 8, or in parentheses to the 2/3, its second derivative with respect to t equals 2 times h minus 24, or in parentheses over the product of 3 pi square root of h and h plus 8, or in parentheses. After being equated to 0, it gives h equals 24. Hence, the maximum rate of change of the depth of water equals -4 square root of 24 over the product of pi and 24 plus 8, or in parentheses to the 2/3, which is simplified to -8 square root 6 over the product of 2 to the 10/3 pi, which is approximately equal to -0.62. In section 3 of part B, since h equals 50 centimeters and dV by dH equals -4 square root of h, the maximum rate water can be added without the vessel overflowing is when h reaches 50 centimeters. The rate at this point equals 4 square root of 50, which is simplified to 20 square root of 2 cubic centimeters per minute. Now let's recall the criteria in part C, which states that the vessel is initially full, where h equals 50 centimeters, and then water leaks out at the rate of 4 square root of h cubic centimeter per minute. When the depth of water drops to 25 centimeters, extra water is poured in at the rate of 40 square root 2 cubic centimeter per minute. The question is to find how long it takes for the vessel to refill completely from a depth of 25 centimeters. According to the above, the differential equation is established to address this problem. The rate of change of water volume, dV by dt, can be written to dV by dH multiplies dH by dt, which equals net water pouring into the vessel every minute, which equals 40 square root 2 minus 4 square root of h. Since we have already know the expression of dh by dv in section 1 of part B, dh by dt equals 4 times 10 square root 2 minus square root of h, or in parentheses, over the product of pi and h plus 8, or in parentheses to the 2/3. Because of the variables of the differential equation are separable, the time t equals the integral from 25 to 50 of pi times h plus 8, or in parentheses to the 2/3, over the result of 4 times 10 square root 2 minus square root of h, or in parentheses with respect to h, which is approximately equal to 31.4 minutes.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.